Okay. Good morning, Betitians. Good day, Betitians. Welcome to our third session of the Breezes Challenge, COGANAT Review Challenge. So our session title will be Compound Interest. First, let us define what is compound interest. Compound interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. So unlike the simple interest is only computed by the principal and by the interest. No, it will not change. Principal will not change, or the simple interest can be computed only once. However, in compound interest, in a specific period of time, the principal will accumulate interest, and that balance or that outstanding balance will be the principal for another compounding period. So basically, that's the difference between the two. So here are some real-life examples of compound interest. First, in savings accounts, so there are many savings accounts that pay compound interest. So your money grows faster over time. So comparing to simple interest, compound interest will grow faster because it will be compounding for every period. So in investment in stocks or mutual funds, your earnings are often reinvested. So you earn interest on both your initial investment and on the gains. And for loans, so this is the downside. So in cases like credit cards, so interest can be compounded, which can lead to debt growing quickly if not managed carefully. So there is a pros and cons of the compound interest. In terms of savings, the money will grow faster, but also on the other hand, in terms of loan, the debt will grow quickly. So this is the compound interest formula. So we have A is equal to P, quantity, 1 plus R over N, quantity raised to N over N. Whereas A is the amount of money accumulated after N years. That includes also the interest. So that would be the final amount. B, that is the principal amount or the initial amount of money being invested or borrowed. R is the annual interest rate written in decimal form. N is the number of times interest is compounded per year. So for example, for determining the value of N for annually, our N is 1. For semi-annually, our N is 2. For quarterly and for monthly, our N is 12. So that would be the values of N. Also, those are the basics terms. For annually, we have N equals 1, semi-annually N equals 2, for quarterly N is equal to 4, and for monthly N is equal to 12. And lastly, T is the number of years. Again, if the years is written or the time is written in months, you need to convert first into years. So this is the breakdown of the formula. Principal, that is the initial amount of money you start with. The rate is the interest rate. So sometimes it is given as percentage. You just need to convert it into decimal by simply dividing it by 100. So for compounding frequency, so just like what I said, semi-annually, quarterly, monthly, or it can be daily also. So from time, the total time the money is invested or borrowed in years. So that would be the breaking down of formula. Now let's have an example. So example number 1, you invest 50,000 in an account that pays a 5% annual interest rate compounded annually. So find the amount after 3 years. So in this case, we have our given. First, we have the principal or our P. Let me change it into P. So our P is 50,000 pesos. Okay. Our R is 5%, or 0.05. Our T is 3 years. And our N, since it is annually, our N would be 1. So using the formula, okay, so the formula would be, so this would be our formula. A is equal to P quantity. Let's go back to the formula. 1 plus R over N raised to N T. So as to the for the solution, we'll just need to substitute the given values to our formula. So our A, we need to find the value of A. So let me write first. Our P is 50,000 times 1 plus our R is 0.05 over 1 raised to 1 times our T is 3. So using a calculator, so first we need to solve for um, inside the parentheses. So that would be 0.05 divided by 1. That would be 0.05. 1.05 raised to 3. So that would be 1.157625 multiplied by 50,000. So that is our total amount or final amount would be 57,881.25. So this would be our answer. Okay. Next example. Next example, you deposit 100,000 pesos. So in a savings account with 4% interest compounded, here we have our compounding period quarterly. And we need to find the total amount for 5 years, after 5 years. So the given are, first, we have our P, which is 100,000, our R, which is 4%, or 0.04. Our T is 5 years, or 5. Our N, since it is quarterly, our N will be 4. So for the formula, again, with the same formula that we have used earlier, so A is equal to P quantity 1 plus R over N raised to N T. For the solution, we just need to substitute all the given values to the formula. So we have A is equal to P quantity 1 plus R over N raised to NT. Our P is 100,000. Our R is 0.04 over 4 raised to 4 times 5. So using a calculator, can solve for that. 0.4 divided by 4 plus 1. 20 times 9,000. So our total amount or final amount would be 122,019 pesos. That is our final amount. So therefore, after 5 years with a 4% interest rate, that is being compounded quarterly, our 100,000 pesos would become 122,019 pesos. That's it for our examples. Now, how can we apply? We can apply compound interest to different real life problems or real life examples, and some of the practical applications of this are first for the growth of your investment. So it helps you to understand how investment can grow over time. So making it valuable for retirement planning. So you can use it for your investment in terms of when you retire, no? So you can compute for your investment. Next is for the saving goals. It shows how much you need to save and for how long to reach a specific financial target. So let's say, for example, um, you have a goal or you have something you need to purchase, for example, a car, no, at least for your savings, especially when it is saved in a bank, you can see how long you will save the amount of money for a particular period of time with a specific interest and if it is compounding or not. And lastly, you need to understand the loans, no, understanding the loans, knowing how much how compound interest applies to loan help avoid excessive debts, no. So in terms of your debts. So you have a debt management, especially with credit cards or loans with high interest rates. So especially for now, there is different credit institution that offers higher interest rates. So you need to be practical and you need to understand how the monies will um, grow quickly. So, quick tips in compound interest. So, if you want to invest, you will start. Definitely, you need to start early. The sooner you start saving or investing, the more you benefit or the more you benefit from compounding. So, again, as the time increases, definitely your investment also increases. So the frequency of compounding, so the more frequently interest compounds, the faster your money grows. For example, if it is compounding uh, annually, no, definitely it's almost the same with simple interest, or if you are just in a year. However, if it is compounding monthly or daily, that's good because your money will grow faster. And lastly, avoid high interest loan. So definitely make sure that if you are going to have a loan, just avoid um, loans that offers high interest and also compounding interest. So high compounding interest rates on debt can lead to significant costs if payments are delayed. So, as a summary, compounds interest allows your money to grow faster over time by building on previous interest. So, it can work to your advantage with investments and savings, or be costly with loans or if interest rates are high and compounding frequently. So, I hope you have learned something. That would be all, and thank you for listening.